Okay, so today what we're going to talk about is the first law of thermodynamics. And the first law of thermodynamics states that the internal energy of a system is equal to that of the heat minus the work done by the system. So the way this plays out is it's a generalization of the principle of conservation of mass. But instead of applying just to a mechanical system, we're also adding heat energy as well. So in order to illustrate this, I'm going to use a pretty frequently used example, but I'm going to try to do it the way that I understand it to explain the concept of the first law. So let us have a cylinder. And in this cylinder, there is a piston with a mass on top. We'll just say this mass is just mass M. And it is pushing down on the piston and exerting force equal to that of its mass times gravity. We know that from Physics 1. And inside at the bottom here contained is a gas. And the energy of this gas we will call internal energy initial, or E, or UI. In order to look at what is the energy of the gases in the system, we can do that by using our formula, PV equals nRT, or pressure times volume equals moles of the gas times our temperature. So what happens if we change one of the variables in this system by affecting one of these? Let's say we change the temperature of the system. What would happen? So let's look at it like this. So let's draw again. Same cylinder. There's the mass, the piston. There's this. And let's stick a little Bunsen burner under it, the flame. And now we are putting heat into the system. Pause, adding heat. And that heat will change the temperature, which will then cause an increase in pressure, which will drive the piston upwards, creating something resembling such. So the piston was driven upwards with the mass, upwards, and the energy required to do that we call work. And that is work made by the system. So now the gas here, we can say that it is at new internal energy of U final. So what the first law of thermodynamics tells us then, very simply, is that this internal energy, or U final minus U initial, equals the Q, the heat added to the system, minus the work done by the system. In this case, it is the piston going upwards. And due to conservation of mass, or conservation of energy, we know then that there is no other factor involved here, and using that we can use it to carry out all kinds of work for useful methods. The steam engine is a very good example of that. But that's my quick intro to this. I hope you got it, and thank you, Professor Kono.